So we want to start off with an easy version of the area problem, since we're just starting out, right? We want to start out somewhere easy where we can make some early successes and then figure out where to go from there. And I'm suggesting that we should start by looking at the graphs of functions. We know a lot about these things already. We can say what the value of a function is. We can talk about its derivatives now. We know that all of these peaks and valleys are governed by the derivative of this function and so on. But it's not immediately obvious to me where the area in this picture is, right? This is just a curve. This is a sine function. It doesn't loop back on itself. It doesn't violate the vertical line test. So where is the area? Or what if I looked at something different? Where's the area here? What should this mean to have area enclosed by a graph? What if I've just got y equals x? Where's the area? So this is a nice and simple curve. It's the graph of a function, but I need to be very clear about what kind of area I'm looking for. So when I graph a function, where can I find my area? How can I calculate this? Well, I would need to have some sort of other bound here. So let's look at the area between the graph of a function and the x-axis. Why the x-axis, or rather x the x-axis? Because it's there, because it's easy. So between this curve and the x-axis, let me fill that in. I can tell Desmos to do this. Show me all y values between 0 and x. Shows up in red. Okay. Well, the further I go out, I can see that this red region here is going to extend infinitely far in the x direction. So let me put one more bound on this and say that x is going to stop at 4. So I can put that here in this formula for 0 less equal to x less equal to 4. So, oh, well, this I can do. In fact, this doesn't need any fancy calculus. This is a triangle. Okay, so it's nice to know that I can actually do this problem already for certain functions. Here, of course, I'm going to get base times height divided by 2. So 2 units of area. Okay, cool. Well, if I had a different stopping coordinate, right? If I didn't stop at 4, if I stopped at 5, have a bigger triangle, it's not too hard to figure out what the area would be then. My base and my height would both be 5. So I would have 25 divided by 2 as the amount of area. And if I change that stopping point, then I get different amounts of area, like this.